So just for fun, I want to do one more of these, and let's do number 52 here. So we've got a lot going on if we were to analyze that one, right? So let's go ahead and think about what would that amplitude be and what would that period be, and I'll use T for period to be more consistent with most textbooks. So amplitude is the absolute value of A. In this case, it would be the absolute value of -3, which is going to be 3. So we're expecting that height to be 3, really similar to that last problem. Our period is 2 pi divided by omega. So we're going to take 2 pi and divide it by -3 pi over 2. So we have 2 pi times -2 over 3 pi. So we're going to see some stuff cancel. So we're going to get 4 over 3. Remember, when we talk about period, we're thinking about that positive value. Actually, when we go back to that definition, they're looking at a positive theta value there, so we could just ignore the negative, in other words. So that's what we expect to happen. So let's graph number 52. So here's the function we're looking at. -3 cosine of pi over 4x plus 2. So we're going to start with our nice parent function, cosine. Our nice points are 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then at 0, the cosine is 1. At pi over 2, the cosine is 0. At pi is at -1. 3 pi over 2 is 0. And 2 pi takes us back to 1. So there's our nice points that we're talking about. So now let's try to graph this guy. We're going to start by looking at left, right. There's no left or right happening here. Left, right happened, remember, when we take that x and we add or subtract some kind of number here. So that's not happening. We do have some stretches or shrinks going on. I'm going to start by that number in front of cosine, and that's going to take all the y values and multiply by 3. So this is, again, a horizontal stretch. Changes the y's. X's stay the same. Now, this pi over 4 is doing something to the x's, right? So we have x, we have y equals 3 cosine of pi over 4x. So what that does is it's going to multiply the x values by the reciprocal, which is 4 over pi. Now, 4 over pi is a number bigger than 1. So this is actually a horizontal compression. I mean, a horizontal stretch. Because we're multiplying by something bigger than 1. So let's multiply these values. Now, some of these may not be very nice. So I'm going to do some scratch work over the side. 0 times anything is going to be 0. Pi over 2 times 4 over pi is going to reduce to 2. Pi times 4 over pi is going to be 4. 3 pi over 2 times 4 over pi is going to be 6. And 2 pi times 4 over pi is going to give us 8. So nice values, but we had to deal with some fractional stuff in there to reduce. And that stepwise stayed the same. So we've dealt with stretches or shrinks. Now we need to do reflections. So that negative in front is going to reflect everything over the x-axis, which changes the sign of y. So x's will stay the same. Y's change signs. I don't know why I keep missing that right here. Once again, I did not multiply that by 3. So go back and fix that. That should be a 3. This has to be fixed 2. This guy should be a 3. And then I've got it correct here. So we have dealt with a horizontal stretch, sorry guys, I don't know where my mind is. This is a vertical stretch because it changed the y values. We had a horizontal stretch here because it changed the x values. And now we did a reflection, which changed the sign of the y values. And then now the last thing is to deal with that +2 on the end. What that's going to do is going to shift the whole graph up 2 units, which means we're going to add 2 to the y values. So -3 plus 2 is a -1, 0 plus 2 is 2, 3 plus 2 is 5, 0 plus 2 is 2, -3 plus 2 is a -1. So let's take all of this and let's graph it on a plane. So my original function was at 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and then 2 pi 1. So I had this wave going on here. And then my last table here had really nice numbers in it, except my Cartesian plane's not nice numbers. So pi over 2 as a decimal is about 1.57. So 1 would probably be somewhere around here. 2 would probably be somewhere around here. 3 is right before pi, because pi is 3.14. 3 pi over 2. So 4 would be somewhere in here. 3 pi over 2 is 4.7, so 5 would be somewhere around here. 2 pi is about 6.28, so 6 would be around here. And then I'm just going to kind of keep these tick marks even. And that should give us an idea of where everything lives. So I've relabeled everything on top relative to where pi over 2 pi, 3 pi over 2, and 2 pi lived. So now let's graph these points. So if I were to put those on the plane, I have 0, -1, and then I'm at 2, 2, and then 4, 5, 6, 2, 8, -1. So big changes happening with this function. That amplitude stretched, you can see that vertical shift happening. Because remember, amplitude is half the distance from here to here. Well, this guy's at -1, this guy's at 5. So I'm a total of 6 units. But if I divide by that by 2, I get 3. So there's your amplitude. Okay, but it's not centered along this axis anymore. It's actually centered more along here, right? So you can see that vertical shift happening, and you can see how my period stretched out here, and that's because of the omega value. So this one had lots of major changes.